Hello everyone, my name is Amanpreet Singh Chadha and you are watching me on KGS Engineers AJ YouTube channel. As you know, this session will be conducted in English and is specifically for those students who are more comfortable in the language English. We will be solving some very interesting questions related to civil engineering. Definitely few concepts you would hear today may very well make you a better civil engineer. So join this session and share it with your fellow civil engineers so that the learning journey can start. My dear student, the batch that we will be launching in June, it will be launching in the first week of the June and syllabus will take 7 to 8 months. So this is not specifically for SSC JEE 2026 because the exam will be conducted somewhere in the later months. So this batch will definitely help you with other exams, specifically for those exams that will be conducted in the 2027. Good afternoon. Good afternoon. Good afternoon to all dear students. Namaskar. So बच्चों, today we will be solving some very interesting questions. You would love them. Good afternoon, good afternoon. And as you know, we are launching the ITI Foundation Batch. Now this batch will help you in securing any JEE examination. So if you are targeting SSC JEE or you are targeting state level JEE or even for any other JEE examination, this batch will make you a much better civil engineer. So we will be launching this batch in the first week of June. And this time we are doing so many things that are for the first time in KGS. So there are some features in this batch that are extremely new, and these features will definitely help you a lot in order to clear your JEE exam. Now, what are those features? What will be the price? What will be the duration of the course? All these questions we shall answer when we will have an event for this YouTube session. So in the first week of June, we will have a YouTube session where we will discuss all the important features of this batch. Once all your doubts are solved, then we will be starting the classes in this batch. Good afternoon. Very good, very good. And one more thing, this batch will have tech as well as non-tech. Tech as well as non-tech. And I give you a little thing so that you can compare it. The price for this batch, I will not reveal the exact price, but the price for this batch where entire tech and non-tech will be taught is, as compared to the other I should say other players of the education industry, the price of this batch is lowest. I can assure you this. If you would compare the price and the quality we provide, first of all, this in itself is a very big achievement to provide such high standards at such low affordable prices. But I can assure you one thing. If you would, whenever I will tell you the price, you would say, so no other player in the education industry provides this price. I can assure you that. Let's move to the question part. Now, today we will be solving some very interesting questions. These questions will definitely make you a better civil engineer. Good evening, good evening, good evening. To be very honest, मेरे बच्चे, surveying is not my area of expertise. I say this very honestly. Apoorv sir is the master in surveying, so I would recommend that you ask him that question. You know my area of expertise, it's all about geotechnical, fluid mechanics, structural engineering. So Apoorv sir is the better person to answer this question. Chalo, let's solve the question number first. The question is, the momentum correction factor is used to account for what? The momentum correction factor is used to account for what? Oh, sorry, I didn't read your question. What is your question, Manish? I am already teaching fluid mechanics, my dear, and yes, I will be teaching fluid mechanics. So momentum correction factor is what? Change in the direction of flow, change in total energy, change in mass rate flow, or non-uniform distribution of velocity. Now the answer is option D. Now a very interesting concept can be taught now. So dear students, if I make the velocity distribution in an open channel, it shows a behavior like this. The velocity first increases and then start decreasing. So near the boundary, the velocity is 0 if the boundary is solid. As we move away from the boundary, the velocity increases. Now by this method or by this ratio, the velocity should keep on increasing and we should get the maximum velocity at the surface. But we do not get the maximum velocity at the surface, we get maximum velocity somewhere below the surface. Now due to this non-uniform distribution of velocity, a change in momentum occurs and a change in kinetic energy also occurs. So momentum correction factor corrects the value of momentum, whereas kinetic energy correction factor corrects the value of kinetic energy. We know that kinetic energy is given as half mv square. My dear student, this v is average velocity. This is average velocity. But here you can see the velocities keep on changing. So when we get the kinetic energy, we need to put the average velocity, but the velocities keep on changing, so we get some error in the calculation. This error is compensated by alpha in kinetic energy and beta in momentum. So alpha and beta, they correct kinetic energy and momentum. The shear velocity V0 is expressed as what? The shear velocity V0 is expressed as what? Very interesting question. Good afternoon. बच्चे अभी we are working on it. Right now we will be launching the foundation batch first, and after that we will go for the recorded batch. So easily for next 45 days we will not be launching the recorded batch. So what's the expression? Option D. So bacho, now how can we determine this value? Now let's take an example of flow in open channel when the flow is uniform. So when gravity force is equal to frictional force, the uniform flow occurs. Now gravity is mg or w cos theta, in fact. So this is w cos theta, which is equal to frictional force. Now W is m into g, m is rho Vg, so rho g volume cos theta into frictional force. Or this is rho g, volume is area into length. If angle is very small, this can be write down as, and this is not sine, this is cos. Sorry, this is not cos, this is sine. Now what is frictional force? This will be shear stress into parameter into length. Now they have asked you that what is the shear velocity. So what is the expression for the shear velocity? Yes, very good. So this rho is compensated here. This rho comes at the denominator. So tau upon rho naught gives you shear velocity. Now this is the match the column. 1, 2, 3, 4. So flow in porous strata towards tube well pipe, whirling motion of a river, seepage flow below foundation of an irrigation work, flow of fluid contained in an axially rotated vessel. Match the columns. Very interesting question. Now, if I make this tube well at the center, so this tube well will attract water from all the directions. So this is a radial flow. So for option A, it is 3. So we can eliminate option B and D. Now whirling motion of a river. So is it option A or is it option C? Very good. The answer is option A, because whirling motion is a free vortex flow, and whereas seepage flow below foundation, okay, the flow below the foundation, this is, we get this value through Laplace equation. So it is none of these options. So answer is option A. The axial load which just produces the condition of elastic instability in a column is known as what? The axial load which produces the condition of elastic instability in a column is Rankine load, Euler load, yield load, or crushing load. The answer is between B and C. This is Euler load. Okay, now answer this question. In case of fluid flow, let's say a fluid is flowing. Now what you have done is you have taken a particle of fluid and you are studying the behavior or the trajectory of this particle. Trajectory implies you are studying the motion of a single particle throughout the course. Now which type of method is this? Is this Lagrangian method or is this Euler's method? Eulerian. So if you are studying a particular fluid particle, you are studying the motion of a single particle throughout the fluid flow. Is this Lagrangian approach or is this Euler approach? Is it both or is it neither? And now this is like a 50-50 contest. Some students are saying Lagrangian and some are saying Eulerian or Euler. So, bacho, the answer is Lagrangian. What happens in Euler is you consider a point in flow and at that point you study all the particles that are passing through. In Euler approach, you consider a point and all the particles that are passing through this point, they are studied. This is Euler approach or Euler method. In the Lagrangian method, what you do is you take a single particle and you study that particle throughout its motion. I give you a very simple example. Let's say I consider a student among you and that student, we study the motion of that student. That student first goes from school to college, then college to, let's say, do for some shopping and then comes back to the home. So here we have studied the motion of an individual student throughout its journey. This is Lagrangian approach. In Euler approach, what happens is, let's say we have taken a point, we have taken a school, and now how many students are entering the school, how many students are exiting it. So when you consider a point and you study all the fluid particles that are passing through that point, it is Euler approach or Euler method. Whereas in Lagrangian, a single individual particle is studied throughout its motion. In fluid mechanics, Euler approach is more common. This is more common. And in fact, this question has been asked in competitive exams. So, bacho, are you getting the point? And this is what we do. In fluid mechanics, most of the time what we do is we take a section and we find out the velocity, pressure distribution, acceleration, discharge at a given point. Very good. Let's move to the next question. The phenomena of decreased resistance of a material due to reversal of stress is called what? This is fatigue. Now, I have a very interesting question for you. Let's say the resilience of a body is 100 joule. Let's say the resilience of a body is 100 joule. Now, what I have done is I have put an external work done of 120 joule. The resilience of the body is 100 joule and I have put an external work done of 120 joule. What will happen to the body? So if I put an external work more than the resilience of the body, what will happen? What is the behavioral change in the body? What change the body will show? If you put an external work done more than the resilience of the body, failure or fracture? Yes, this is the word I am looking for. This is permanent deformation. Permanent deformation. So if an external work done more than the resilience of the material is applied on the body, then the body permanently deforms. And permanent deformation does not mean fracture. Fracture implies the breakdown of the material. The material is separated into two parts. This is fracture. Failure implies permanent deformation. When you take the load apart, when you remove the load, the body does not come back to its original position. So failure does not mean fracture. Failure means yielding. Now, if the toughness, let's say the toughness of the material is 200 joule and external work done is 250 joule, what will happen now? So if I put an external work done, if I apply an external work done of 250 joule, which is more than the toughness of the body, what will happen? This time the body will undergo fracture. Fracture implies the breaking of the material. The material is separated into two parts. So toughness is the maximum strain energy you can apply on a body without breaking it. Toughness is the maximum strain energy you can apply on a body without permanently deforming it. Stress, strain. This is the rupture point. Now, if I take the area up to rupture point, what I get? I get resilience or I get toughness. If I calculated the area of stress strain curve up to rupture point, what do I get? Which parameter I get? Resilience, toughness, something else? Now up to rupture point. Now here this is what I have just mentioned. So in case of toughness, this is the maximum strain energy you can apply on a body without fracturing it. Fracture and rupture is one and the same thing. Yes, this is the word I was looking for. You will not get resilience, you will not get toughness, you will get modulus of toughness. And how can you conclude this? Bache, if I ask you that what is the unit of the area of the stress strain curve? So when you determine the area of the stress strain curve, it is stress multiplied by strain. Stress is kilonewton per meter square and strain is dimensionless. Whereas the unit of resilience should be kilonewton meter. Kilonewton meter is joule. So we are not getting the unit of energy. So what is the parameter we are getting through the area of the stress strain diagram? This is energy per unit volume. Strain energy per unit volume. So strain energy is what? Kilonewton meter. Energy is work done is force into displacement, and volume is meter cube. So kilonewton per meter square. So always keep this in your mind that the area of a stress strain curve does not give toughness or resilience. It gives modulus of toughness or modulus of resilience. If you take the area till rupture point, this will give you modulus of toughness. If you keep the area up to elastic limit, this will give you modulus of resilience. Now, just answer me one more question. If you want to find out the toughness of the body, let's say you want to find out the toughness of the body. So, the area of which graph will you give? Which graph? The graph between which parameters give you the toughness of the body. Stress strain graph does not give you the toughness of the body. So which graph actually does? Graph between those which parameters give you the toughness? Very good. This is load deformation graph. So the area of load deformation graph gives you the toughness. If you draw this graph up to the rupture point, you will get the toughness. Very good, very good. Now, bacho, I am asking you a very, very, very interesting question. You would love this question. It's like that the time you have spent so far in this session, this time is fulfilled. The question is, in order to understand the material behavior, whenever we study about the material properties, be it brittleness, be it elasticity, plasticity, ductility, malleability, we always draw stress-strain diagrams. Why don't we draw load elongation diagrams? When you study strength of materials, when you go through material properties, you always find the stress-strain curves. Why don't you find load elongation curves? In UTM, in Universal Testing Machine, we actually get the load and deformation. We do extra calculations and convert this load and deformation into stress and strain. So why are we doing this extra calculation? Why are we not studying the material behavior in terms of load elongation curve? Now this is a very, very, very interesting question and you will love this. Now first of all, please answer me. Are you getting the question? That why do we draw stress strain diagrams and not load elongation diagrams to understand the material behavior? You can only understand the answer when you first get the question correctly. I hope you are able to understand what the question is. Okay, now this is the first part. The question is absolutely clear. Now I give you a very simple explanation and trust me, I believe 1% of the civil engineers in the entire nation know this answer. So, bache, what we do is, when we try to understand the behavior of a material, let's say you have a material to which you want to draw some beam. You have a material and through this material you want to build a beam. Now, what you try to do is you try to understand the behavior of this material in the laboratory first. So, you have a beam and let's say you have a material and through this material you want to make some column. Now, in your design, you have to make a column, let's say of square cross section with 1 meter length, 1 meter cross section, and let's say 1000 kilonewton of load is to be applied. So, what I am trying to say is, let's say you want to analyze the behavior of a material which will be subjected to a 1000 kilonewton load in the site and the cross section of this column is 1 meter into 1 meter. Now, in order to understand this behavior, you want to see that either this material will stay safe or will it fracture or fail. So, what you need to do is the exact same conditions you will try to have in the laboratory. So, in the laboratory, you have universal testing machine. So, what you would try to do is, in order to make the exact specimen, you need to make a specimen which is 1 meter into 1 meter. And then you need to apply the load of 1000 kilonewton in the laboratory in order to predict the behavior of the material. Now, this is very unpractical. This is not practical. This is impractical. Why? To make such a large section in laboratory is not possible. So what we would do, how to determine the behavior of a material? We cannot do this in the terms of load and the actual size. Now, the load of 1000 kilonewton is applied at a cross section of 1 into 1, means 1000 kilonewton per meter square is the stress. Now 1000 kilonewton. I converted this kilonewton into Newton and meter square into centimeter square. So 1000 kilonewton per meter square is actually 100 Newton per centimeter square. Now to make a cross section which is 1 centimeter into 1 centimeter is extremely easy, is easy and it is possible. You can easily do this. To apply a load of 100 Newton in the laboratory, it is also possible. So the answer of the question is that if we try to duplicate the situation of the laboratory and the site, it is very difficult to apply the exact same load at the exact same cross section. In terms of loading, this is extremely difficult. So what we do is we convert the load into stress. The effect 1000 kilonewton on 1 meter square is same as the effect of 100 Newton on 1 centimeter square. Now this can be made, this can be achieved in the laboratory. So what we do is we never try to replicate. Replicate का मतलब होता है duplicate करना, है ना? We never try to replicate the load at the site in the laboratory because it is extremely difficult. We need to make the same size of the specimen. So what we do is we try to go for the stress. So the effect of 1000 kilonewton on 1 meter square is same as 100 Newton on 1 centimeter square. The 100 Newton load can be easily achieved in the laboratory and the 1 centimeter square cross section specimen can also be easily made in the laboratory. This is the reason. In order to understand material behavior, we never go for load deformation curve because this load and this size of the specimen is very difficult to maintain in the laboratory, but we can go with the stress part. The stress that is material experiencing in the site can be achieved easily in the laboratory. This is the reason we draw stress strain curves rather than load deformation curves. बच्चों समझ आया क्या? Very, very, very good. And this is the purpose of any YouTube session that we conduct on this platform, to impart knowledge. The purpose is not just mere a formality of solving some questions like that today we will be solving 30 questions or we will be solving 40 questions and just one word questions and we move to the some other session. No, the purpose is absolutely clear in our mind that we want that whosoever join this session becomes a better version of himself or herself. This is what the purpose is. And once you gain the knowledge, I have told you this so many times, once you get knowledge, you get confidence. Once you get confidence, everything related to you changes in a very positive manner. The way you talk, the way you walk, everything starts changing once you have the knowledge. The maximum shear stress occurs where? So maximum shear stress occurs at 45 degree to the principal planes. Theta S is theta P plus 45 degree. My dear bachcho, now I have a very simple question. Now can you prove this to me, why at 45 degree the plane of maximum shear is obtained? Just give me a yes or no. Let's say if I ask you, can you prove it? That how you concluded that the plane of maximum shear is obtained at 45 degree to the principal plane. Would you be able to derive it? Very good. If you are able to derive this, this is what the meaning of education is. Very good, very good. Total elongation of a prismatic bar of length L, weight W, cross section area A and a modulus of elasticity E under its own weight while hanging vertically is what? This is extremely easy, simple formula based question. Elongation is WL upon 2AE. And one more thing, make sure you can derive the expression, because in the derivation of this expression you consider a strip, and this concept of strip is used in other derivations also. So this is what I keep on saying, if you learn a concept, that concept is used in so many other ways also, in so many other concepts also. This will only make you better. The ratio of maximum shear stress to the difference of the two principal stress is what? Easy. Tau max is difference of the principal stresses divided by 2. So this is 1 by 2. A cantilever is loaded as shown in the figure. This is the way a cantilever is loaded. What is the shape of the BMD? Is it uniform, uniformly varying, zero, concentrated at the free end? What is the bending moment along the length? Bending moment is zero. How? Now, in order to eliminate the confusion, apply a load P here and a load P here, assuming that this distance is half. Now, this forms a couple, a clockwise couple of magnitude PA by 2, clockwise couple. And these two, they form an anti-clockwise couple. ठीक है? That's it. Pakka. Pakka moment is balancing. Apply a load P here and a load P here. Now watch these two. P and P. A by 2. So this is a clockwise moment of PA by 2. Now this part. This P and this P. This is A by 2. What is the direction of this moment? Again, this is clockwise. and the moment is P by 2. So both the moments will be added up. So it will be P into A. Both are of the same nature, बच्चों. Both are clockwise. So both are to be added. And when a moment is applied at the free end of the beam, which type of bending moment you get? If there is a beam which is subjected to a bending moment at the free end, what will you get along the length? You will get a uniform bending moment. Almost everyone gave the wrong answer in the beginning. You were all cheering for option C, but the answer in fact is option A. Consider the following statements. Statement first, second, third. Point of contraflexure is the point where the bending moment is maximum. Point of contraflexure is the point where the bending moment changes sign. Point of contraflexure is the point where the shear force is 0. Which of the following is correct? Good evening. This one is easy. I thought this was easy for you, but this is not easy. Let's consider an overhanging beam with a UDL. This is L, this is A, this is A. Or not even UDL. With a point load. This is W, W, W. This is L, A, A. L by 2, L by 2. So if L is greater than 4A, then this is the bending moment diagram. Now if I draw the shear force diagram, it will be like this. So at the point of maximum, or I should say at point of contraflexure, where does the shear force is 0? You want to change your answer to option C or you are sure with option B? Okay, let's play Kaun Banega Crorepati. Let's play this. So Deviyo or Sajjano, you are willing to change your answer to option B or not? Are you willing to change your answer to option C or you will stick to option B? Now let me give you one more example. This will, you can easily understand. Simply supported beam with a central bending moment. Shear force diagram SFD is constant, but bending moment diagram is like this. So this is the point of contraflexure where the bending moment is changing sign, but shear force is not 0. So this is not mandatory that at the point of contraflexure, the shear force is always 0. So it should be answer option C. This statement is not always correct. The shear force diagram and bending moment diagram are given. Which one of the following is the loading? Shear force diagram is constant. It implies a point load and moment X at the beam. And then let's see bending moment diagram. So at the free end, bending moment is 0. It implies the point load is acting at the free end because at the free end shear force is 1 and the moment is not applied at point at the free end. Otherwise, if a moment is acting at the free end, then bending moment cannot be 0. So if you go for the options, मतलब options 3 kilonewton meter की figure कौन सी है? Let's see, we come at here 2 and 3. Figure is incomplete in this question. So this is the 1 kilonewton load, 1, and then here 2 to 5, 3 kilonewton meter. Same rotation. Figure is incomplete, but this should be the loading. Okay. B option. Oh, bhai sahab. A pin jointed lower truss is loaded as shown in the figure. The force in the member DF is what? The force in the member DF. This one is time consuming. This question was asked in engineering services. I give you a hint, try to solve it on your own. If you are unable to solve it, then I will solve it in the next session. We will use the method of sections. A bit time consuming question. But this was also the last question. So we will solve, first of all, try to determine the reactions. Once you get the reactions, then summation of forces you need to balance. C per load, C per, acha, oh, even I am also not able to find this one. I guess this is 2 kilonewton. Even I am not sure. I will check this question. Just mail me, sir, to check this question. But yes, this question was asked in engineering services. This is very much solvable, but yes, it will take some time. तो प्यारे मेरे बच्चों, we are done with the session. But I hope you liked this concept that why do we draw load elongation? Why do we draw stress strain curve in place of load elongation diagrams? Chalo, very good, very nice. Now we will be meeting tomorrow at 11 a.m. in that Hindi bilingual session. So again, tomorrow we will be solving some very interesting questions, and make sure you share both the sessions at 11 a.m. and at 4 p.m. with your fellow civil engineers. We want that more and more students get benefit from these sessions. अब मेरा मेल नहीं पता. My mail ID is amanpreet.c@kgs.live. Thank you. Hello, I'll see you tomorrow. Till then, do take care. God bless you. Thank you. We'll see you tomorrow. 11 बजे हिंदी सेशन में.